All right. A farmer has 200 feet of fence with which to enclose a rectangular animal pen using a long outbuilding as one side of the pen. If the farmer wants to use all the fencing, by the way, why wouldn't a farmer use all the fencing if he's going to enclose the maximum area? And have an animal pen that encloses 4,000 square feet. What dimensions should the animal pen be? Now, like I've said before, there's very few people going to read that and say, "Oh, I know how to set up the problem right away." So don't sweat about that. Don't let that worry you. Let's draw a picture of the situation, right? Let's draw a picture of the situation. So there's some long outbuilding, right? This is the outbuilding, right? And the farmer is going to do a pen that is, say, like this. And inside here is 4,000 square feet. Okay. Question. I have 200 feet of fencing. What determines my area? Now, I should do this. So this right here, this bold part there, that's my fence, right? This building probably should have made it a different color, right? Let's see here. We can change things around. All right, there you go. So the blue is the fence. And so all of this has to sum to 200 feet, right? There's more than one way that somebody could set this up. The first way that comes to my mind is how far you come out from the building is going to determine your area. And so suppose this distance is X. How far I come out from the building. It's rectangular. The pen is rectangular. This dimension here would be 200 minus 2x. And then if you add all those up, you get 200. Okay. All right. Everybody okay on the setup? I mean, there might be a different way. I could probably think of a different way. So we have some relationships up here. We have some relationships up here. We know that it's got to be 4,000 square feet. What are the dimensions here? So length, and it might be useful to you. You don't have to do this, but it might be useful to you to summarize in sort of a mix of English or your language and math. Okay? It's not part of the problem. It's not required. But you might say something like, well, length times width is going to equal 4,000. So that's kind of in language, natural language, and math. You don't have to do that. But we say, okay, our length, let's call this the length. Our length is 200 minus 2x. See, this is what your drawing allows you to do, because it forces you to name things. It forces you to call something x. And you want to know what the dimensions are. What dimensions should the animal pen be? Well, you see that the area of the animal pen depends on how far you come out from the building. And if it's rectangular, those two have to be the same. So that's the length times the width equals 4,000. Now, there's a couple of ways we can go about doing this, right? We need to solve for x. We have to solve for x. Well, let's see. How might we do that? Well, let's multiply this out. 200x minus 2x squared equals 4,000. And I'm going to put everything on the other side. And so I'm going to have, if I put the 2x on the other, 2x squared on the other side, I have 2x squared. 200x goes on the other side, that's minus 200x. 4,000 is already on the other side, that's 4,000. And this side then would be 0. So you have a quadratic. Okay. We're lazy. In fact, most of us are what? We are okay. And so Diego's going, maybe I want to go back. Maybe that intermediate algebra wasn't so bad. No. Was it? Okay. So let's. We're lazy, so we're going to cancel stuff. We like smaller numbers when we can have them, right? So this is the same as x squared minus 100x plus 2,000 equals 0. We divide it by 2. Okay. Now, what we want to do is we want to solve this. We can plug it in the quadratic equation, right? Get answers that way. Another way we could do this is with the calculator. Now we're talking. So we go over here. Off. Let's go up here to our calculator. And we need to we want to solve this equation here. X squared minus 100x plus 2,000. So x squared minus 100x plus 2,000. And yeah, let's graph that. Let's graph that. Let's graph that. What happened? This is where I get a hand in the middle of the test. Mr. Miller, my calculator's broke. Right? Well, what has happened is you're graphing this right here, and the calculator did graph it, but there's no graph. What it is you're looking at a part of the Cartesian plane that has no graph on it. That's the problem. You're looking at a blank spot of the plane. So you need to adjust your window. Now you ask yourself, well, to what do I have to readjust my window? In other words, what should you adjust your window up here, right? I need to make my window bigger somehow or move it. How do I find points on my graph? Well, one thing for sure, when you have a quadratic, and for that matter, any polynomial, we graphed the corresponding function. We graphed this function here. And this is the y-intercept. Don't believe it? Plug in 0. Oh, by the way, okay. I'm only going to do this once. I'm only going to do this once. Why? Because I'm an old man. Ready? How do you get the y-intercept of any function in the universe. Ready? Plug in 0. This professor is really stupid. You know what? It works. It works. Right? It works. That's how you get the y-intercept of any function. Plug in 0. So if we plug in 0, that's 0. That's 0. That's the y-intercept. Right? Okay.
That was easy.
So we need our calculator screen. It's going up 10, 10, 10, 10 from the origin, 10 each way from the origin. Well, I got to go up to 1,000 just to get to the y-intercept. You see the problem? Yeah, we have a problem. Okay. Now another thing I can do is I can go look at a table. Right? The table function is right here. Table. The blue function above that last key. Second table. Oh, look at that. Oh, here 0, 2,000, 10, 1,100, 20. So you see about how far I need to go out in my x direction. So I need to go out to like at least 100 in the x direction. Because look here, I have positive values, then they turn negative. Well, they turn that means I have a solution in there between those two. It goes from positive to negative, it had hit 0, right? That 0 is one of my solutions to my problem. Then negative, 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 positive. So between 70 and 80, I have another solution. You see? Now, I happen to have my table settings, and this is coincidence, that it gave me that information right away. But if you need to play around with them, you go to second table set. Second table set. And here, I wanted my table to start at 0. I wanted it to advance by 10 units each time, right? And that's what it did. Second table, that's what I got. So now this gives me an idea what my x and y minimum and maximum should be for my screen, right? So I'm going to go back to my window and say, okay, x min. I know x max is going to be like 100 and something, right? So x min, say, I don't know, minus 20. X max, 120. You can always change these. X scale, I'm going to put 20. And let's do, you know what? Let's do 10. Y minimum, I don't know how far down it goes, but if I'm going to go up to 1,000 or even higher, I'm going to go maybe down at least 500 maybe. I'm just guessing. I don't know exactly. 100. Make that. Oh, X max. Sorry. Clear. Let's make that 1,500. Yeah, I think minus. X scale 300 maybe. You don't have to put those exact figures in, but something like that should capture some of the graph. That's my point. I should have graph on this one. So I hit trace. There we go. Oh, I still don't have my y-intercept, but that's okay. Because look up here, I'm only going up to 1,500. My y-intercept is at 2,000, right? So I go 2,500 maybe there, right? And now, there you go. I got my y-intercept. It's going below, goes up. Okay. So these are my solutions right here. The x coordinates of those two are my solutions. Now let me tell you how to get a partial credit answer. Is you go, okay, you go along the graph with your arrow keys, and I need to get the x coordinate right here. And so I go very close. I go, oh, that's pretty close. X is 27.7. That's close. And for your application, that may be close enough. But in here, I want you to be able to find the exact value. So I want you to be able to use the technology to find the exact value. So second trace, I mentioned before that you're going to be responsible for the first 5 functions on the calc menu. Second trace gives you the calc menu for calculate, right? You're not responsible for 6 or 7. Those are calculus functions. All right, so I want to know where it's 0. So I'm going to hit number 2. So it says find a 0. It's going to ask for a interval, left and right bound of an interval, in which to look for a 0. So I want to find that 0 there. I go a little bit to the left, anywhere to the left. As long as it's to the left of my 0, hit enter. Now, if you have one of the new calculators, like I said, it's going to put this vertical line on the screen. If you have one of the older ones, it won't. So your 2 calculators, it will not show that vertical line in the back. Yours should show that vertical line. Okay. And then it's asking me for a right bound. So I just go anywhere to the right of my 0, anywhere. Right there is fine. Enter. So it's going to look for a 0 in that interval. And so even if your calculator doesn't have these vertical lines, it has these 2 marks up top. So look for those. And that works fine. That works fine. If there's only one 0 in the middle, you don't have to even enter a guess. Just hit enter again. And 27.64. Because I had 27 point something before, you know, it's close. But that is right there is your exact answer. So you have, if you look back at the screen over here, that's one of your answers right there. Right? That screen's right there. The other answer, 72.36. What's going on there? Why are there 2 answers? The reason why is there's 2 sets of pin dimensions. Okay, I'll get to that in a second. Does everyone understand how we get to 27.6? We got a 0 of that on that parabola. And then if we get the other 0, it's 72.36. And just real quick, let's get the other 0 just to show you, right? Second, right? I want 0, 2, second calc, 0, 2. Left bound. I'm going to do maybe, I'm just going to guess 60. You can enter a number. Oh, good. That put up that. Right bound, 80. So as long as I have that intersection in between those 2 points, I'm all right. Hit enter again, and that gives me the 72.36, right? So you should know how to do that. You should be using that as you do your homework and your problems. You'll be required to do enough by hand, but I encourage you to use your calculator to its fullest capability when you're allowed to, which is most of the time, but not all the time. So here, my answers are, we have 2 solutions, right? One's here, and the other one's here, right? So you have x equal 27.36. Oh, you know what? That's 27 point, did I say 36? I'm wrong with that, aren't I? X equal 27.64. Yeah, 36. What am I doing? And then over here, I have x equal 72.36. There's my 36. Okay. I have 2 solutions. Now, what does that mean? That means there's 2 pin dimensions. One of them is if I come out 27.64 feet, that gives me 1 dimension of a pin. So that will be the what I called here the width, right? The length is what's it going to be? 200 minus 2x. That's the width. And so that's going to be 200 minus 2 times 27.64. And that is 200 minus 55.28, which is 144.72 feet, right? And so 1 is going to be 27.64 by 144.72. Always includes your units. So feet symbol is that. Or you could just say feet. So that's 1 pin. And that pin will be wider than it is tall. So there you have the 144.72. But we have this other solution. What's going on there? Well, it turns out that you can have a narrow pin that comes way out. That. You can have a narrow pin that comes out. So it comes out 72.36. And so what is its width? So 200 minus 2 times 72.36. That is 200 minus 144.72. And the width is therefore going to be 55.28. Okay. So the second pin is 72.36 feet by 55.28 feet. Now, you can check your answers here. If you multiply these together, you should get 4,000 either way, or very close, because we rounded. Okay. Okay. All right, so that's a, let's go through that again real quick, and then I want to make sure I get any questions you have. All right, probably the most important step here, in my opinion, is a graph, a good graphic. Most of us are visual, right? And a visual when it comes to math. And so you have the big long outbuilding, you have some pin that's going to be 4,000 square feet. The rectangle is going to be determined by how far you come out from the building, and you have 200 feet of fence altogether. So you come out from the building X, and the width is going to be 200 minus 2X. We turn that into a function. We multiply it out. We set it equal to 0. And then this is a key step here. This is a key step right here, because this function is what we enter to our calculator. So every quadratic equation has a corresponding quadratic function. And it's the function that your calculator can graph. You don't graph equations. You graph functions. So we put that into our calculator. We had to play around with the window and all that. And we wound up with this parabola. Right? And we found the 2 zeros. So that gives us the 2 different measurements of how far we can come out from our outbuilding and have a pin of 4,000 square feet. The first one was 27.64. That leaves the other dimension at 144.72. 200 minus 2 times 27.64. Similarly, the other one was 72.36. I put it in purple here, so it corresponds to the purple here. But this came out to over here, 55.28. Okay. So those are our 2 solutions. Any questions? Yes, sir.
Can you go back to the Windows settings?
Window. You don't have to have exactly the ones I had. But one rule of thumb is that for X min and X max, you want one to be positive and one to be negative, because you want the axis to be included on your graph usually. And your axis won't be included if they're both positive. You won't have that axis. And then the second thing is if you get kind of lost and you don't know what to put into, actually find some of the graph, look at the y-intercept. How do you find the y-intercept? Plug in 0. I only do that once per semester, per class. Right. It bugs me when I have to do it in calculus class. Okay, so so I use the table function to find out the values. When I go table, these are actual points on the graph. I know if I include these values somewhere in my window settings, these values are included, I know I'm going to hit some graph. And then I can adjust from there. Oh, I need my X max to go out some more. Or I need my Y max to go up more, or whatever. All right, so yeah, that's my window section. Other questions? That's part A. Yeah. All right, I know. Mr. Miller. Switch to decaf. Why switch to decaf? Part B. What is the largest possible area that can be enclosed with 200 square feet? What's the largest possible area? Well, that's interesting. Okay. In other words, if I had 200 square feet, 200 feet of fence, linear feet, and I didn't want to enclose just 4,000 square feet, but I wanted to enclose the maximum possible, what would that be? Well, your area is length times width. And if I go back and do this same, if I did that same drawing, you don't have to put, what? That is strange. You don't have to copy that again, because you have it on the slide above, right? But you see that the area is length times width. That's going to be, what's my length? 200 minus 2x. My width, x. So that's going to be 200 minus 2x squared. That's my area. Oh, yes, thank you. Yes, thank you. 200x, yes. So I'm going to graph that. That's a parabola, right? That's a quadratic. It's got a negative x squared coefficient, so it's going to open down. What's the y-intercept of this? 0. So if I plug in 0, each of these is 0, right? So your y-intercept on any polynomial function, the y-intercept is always the constant term. So in the last problem, the constant term was 2,000. That was the y-intercept. Here, the constant term is 0. So I go up here, and here's what the graph is going to turn out to be. But you go to your calculator, right? Y equals clear. Oops, what am I doing? Clear. So I'm going to do 200x minus squared, right? And just try the old graph, see what happens. Whoa, it's off the graph. Here it comes back down. So that tells me I got some work to do in my window settings, right? I need to find what the top is here. It's going to be a lot higher than it is now. So I go to my window settings. I'm going to leave everything the same except for Y max. That 2,500 is going to go up considerably. I'm just guessing, but maybe 5,000. And let Y scale be 500 or something, okay? Oh, wow, look at that. All right? And so what I'm going to do here is what? Second calculate. I want to know that maximum. 4. Left bound, anywhere to the left of the top. Anywhere to the left, hit enter. Right bound, anywhere to the right of that top. Hit enter. Enter again. And so the maximum occurs at, you notice this is way over here, right? Round to 2 or 3 decimal places. You don't need to write all that out. But 50 times 50 gives you a maximum area of 5,000. Do you have a question?
I came out with 49.999.
Yeah. That can have, it's 49.99987 or something. Yeah. Rounded to like 2 or 3 decimal places. That's very common, actually. Mine didn't come out to 50 exactly either. Yes, sir.
I can't figure out the window. Like, how do you decide what to put in the window?
Okay. Well, as well as saying a little bit what I was saying earlier is number one, look for your y-intercept. Make sure your y-intercept's included. Number 2, I would use the table. So your table settings go second table set and put in 0 for table start, like I have here, and 10. Go up by 10, let's say. All right. That will provide you some basic values. And then to graph that, or to get the tables, to get values on that second table set, or excuse me, table, with this table right here, second table. And so these are actual values on your graph. So your window settings need to include these values. So if your Y, for example, doesn't go up to at least 5,000, you're not going to get all the graph. I barely went up enough, right? And so your X's had better go out to at least 100, probably like 120.
I don't even have a Y on mine right now. I must have somewhere.
Do you have a function? Do you have a function entered?
I thought I had the one.
Yeah. If you don't have a Y, it isn't finding a function.
I'm probably deleting it. Yeah. So I have it.
Yeah, you don't have any function. So type that function in there. There we go. Alrighty. Let's go back over here. So we wound up with 5. Now, there's probably another way to have arrived at that, right? Because, for example, this is 2, and then you have 100 you know what? I'm going to let that go. I had a thought, not worth it. If you understand how to get it that way, that's the way to do it. There are other ways. There's formulas to get that vertex. Questions? All right. Now, this one we'll probably have to go over the next time. All right. Promoters know they can fill a 7,200 seat arena if concert tickets are $60 a piece? $60 a piece. Based on sales numbers from previous concerts, management estimates attendance will decrease by 40 people for every dollar increase in ticket price. So the higher you raise the ticket prices, you're going to lose a few people, price a few people out of the market. And we all know concert people, they don't want to price anybody out of the market, right? Have you ever been to a concert lately? Yeah. Even for bands and for old people like us, it's nuts, right? It's nuts. It is crazy what these people do. Some of these guys, from when I was in high school, they're 75 years old and they're still getting $150 a ticket to a concert. My wife and I went to see Ringo Starr a couple of years ago. The Beatles. It was a very good concert. That guy packed this arena in Lincoln. Packed it. He's 75 years old. Oh my gosh. All right. What is the fewest number of tickets promoters can sell and still receive $500,000 in revenue? Now, I want to tell you right off, this is a real type of a business problem, is it not? And it takes levels of thinking. It involves all the math that we already know, though. It's the levels of thinking. And there's one like it in the book. This is similar to this example in the book. Where we need to start is I want to know how much should I price my ticket, right? What's the fewest number of tickets promoters can sell? So I'm interested in the number of tickets sold. Oh dear. And I want 500,000 in rep. Oh my. Right. So I'm gonna let my X, let X equal, how many dollars do I raise it above 60? So I'm gonna say dollars above $60 ticket price. And it's asking, you want to set up a formula for what the question is asking for. The question is asking for revenue. What is revenue? Revenue? I'm going to call it capital R of X equals what? Tickets sold the number of tickets sold times price per ticket. Okay? Question. Why did I pick X to be dollars above $60? You could do X just be ticket price if you want. But one of these two, it turns out in this problem, is going to be complicated, either one you do. So now ask yourself, for every dollar above 60, I'm going to lose 40 people in attendance. So the number of tickets I'm going to sell is what? 7,200 minus however many dollars I go above 60 times 40. So I'm going to lose 40 people times how many dollars I go above 60. By the way, this is the most important step right here. The rest of the problem is the calculator, basically. What's the price per ticket? 60 plus X. So this is key. This indispensable key. Now, I want to know which values of x give me 500,000. So I want to know, I need to solve 500,000 equal that. Okay. Well, here's how I do this. This is a case where I would graph this in 2 stages. You know what? We're out of time. There's only 30 seconds left, so we're gonna leave this till Friday. We'll leave this till Friday. Now, if you're smart, you're gonna be doing the homework in this section. All right. So this the homework is listed in the slides a little while back, back on slide 19 actually. And so I listed it there so you can be doing it as we do the rest of the slides in the section, because the homework for section 1.1 is due the class after we finish 1.1. All right. Anyway, I'll see you on Friday. Oh, by the way, next Monday, I'll be at Spark, the Spark session, the thing in the academic. It's no longer called the library. It's in the building formerly called the library. The Academic Resource Center in Levitt is the technical name now. That's a mouthful. I think I'm just going to say library. See you guys. Oh, okay, here, yeah. We'll just, you guys, if you have any homework, just put it here on the way out. Thank you. Thank you very much. Just put it right there. Yes, sir. Okay.
Now you can give me a right. Here, that's like a 340, 20% profit right now. 20%, 340. 6.68, I added 340 to that.
Yeah. Here's the problem. If you take that 408 and you're saying that there's a 20% profit, the cost of the product, if the retailer wishes to make a profit of 20% on the selling price, what should the product be sold at? So watch this. So if I take 80% of that, I don't get 340. That's the problem. So what you have to do is you got to do 340 and divide it by 0.2. The equation you're setting up here is the selling price times 0.8 equals 340. All right. So you take 340 divided by 0.8. Divided by 0.8. There's a 425. Now, the 425, if I multiply by 0.8, a 20% markup, gives me 340. So it's off the selling price. That's the key part there.
If you get the retail price, you need to be inverse of the 20%, the 80%.
Yeah. You might figure this in. Yeah. That's a good question. Yep.
I have to do the live. I will do the live. On this live. I have to buy a calculator and
From somebody. Or if you know Brooklyn Windquest, she's a student here, you can email her. She's got one for sale. The slides I give you, okay, the book should be coming in soon.
yes, I know.
Don't worry, I'm gonna, if you don't have a book, I'll be merciful on your deadline. Not on yours. You see, he's already on it. He's pumping out. I know she's done. He's pumping out. See that? He's pumping. So, don't worry about not having a book. You know, we're gonna make sure you have plenty of time. But I would be studying, maybe get with your guy there again, you know, study with him. He seems like a good student. I don't know. I haven't had any tests yet. Right. And and so was the other class like too easy for you, or?
Yes, because in Spain I did like a lot of, we didn't use a lot of the calculator, but we do like hardest problems and with derivatives.
Yeah, your European school was so much harder and better.
I think that
So no, I was in Italy for 11 years, and the Italian schools the same way. The Italian schools, none of the stuff that you see here. Yeah.
I think that is very hard.
Every European student I've ever talked to has told me the same thing.
Yes.
Everyone. From Germany, from France.
And in math, I think that is the same, you know, the most different.
I agree. I totally agree. There's another girl from Spain there you might know her.
Amaya.
Amaya. Yeah. She I've had her in class before. She's a good student, and she said the same thing. She's in Paloma.
I had to do like a lot of problems to pass my.
Well, I'm here to help you. Hey, thank you for coming. Let me know how I can help.
Thank you.